Hello everyone, my name is Rana Mesquita. I'm a machine learning engineer and an MLflow ambassador. Welcome to the first part of a two-part video series on agents evaluation and observability. In this first part, we will learn how to evaluate a simple RAG agent using MLflow evaluation framework. We will start by registering the agent. Then we will capture its traces together with ground truth expectations and run a multi-framework evaluation, where we will combine judges from Hugging or Rice Phoenix together with custom judges and a deterministic scorer. Then we will use these evaluation results to guide the agent iteration and improvement. In part 2, we will take this one step further, and we will be aligning the custom judge that we created in part 1 with the subject matter expert feedback. The goal is to create an alignment lifecycle where we will be collecting the SME feedback and aligning the judge using MLflow memoline. I have written a medium story for each part of the video, so check the links in the description below. So let's get started. Let's start by understanding our use case. So in this video series, we will be building a RAG agent that will answer children's questions. It will answer questions like, what happens if I miss too many classes? Or can I use my phone at school? To answer these questions, our agent will retrieve relevant pieces of information from a school policy document, and then it will generate child-friendly answers. Our agent we will build using three main components. We will be using LangChain to orchestrate our code. We will be using Phase as our vector store for fast similarity search during the retrieval phase, and we will be using Amazon Bedrock to connect with foundation models. All the source code that we'll be using is available in a repository, and the link to it will also be in the description below. The code is organized in a modular way. Inside the source folder, you will have the code for the agent definition, everything that you need to set up your evaluation framework, together with all the utilities that you need to set up your vector store. Each step of the process that I'll be describing has a corresponding script inside the scripts folder. The first thing that we are going to do is to register our RAG agent chat prompt into MLflow Prompt Registry. The MLflow Prompt Registry is what allows us to manage the life cycles of our prompts with versioning and aliasing. So let's look into our prompts. We can see that we have a system message. This is where we instruct our agent to act as a school assistant that will answer the children's question, and he also should provide child-appropriate explanations. We can also see that we have the user message here. And in the user message, we have the placeholders for both the context. This is what will be retrieved from the vector store, and the placeholder for the student question. Okay, so now let's look into how we can register this prompt into MLflow Prompt Registry. As I said in the beginning, everything that we'll be running today will be inside the scripts folder. So you can see that you have a registered prompt here with the code that we need to register our prompt. We start by configuring our MLflow tracking server and also setting the RAG agent experiment. We do this for every single step to ensure that all agent assets from prompts, agent versions, traces, and evaluation runs, to ensure that they are all logged under the same experiment. Okay, so after the MLflow setup, we can call the mlflow.genai register prompt. This is where we will send the prompt name together with the template that we already saw previously, and some tags as metadata. If the prompt does not exist in the MLflow prompt registry yet, this call will be creating it. Otherwise, if we already have a prompt registered under this name, it will create a new version and append it to the existing prompt. Once the prompt is registered, then we can set an alias using the MLflow GenAI set prompt alias. Here we will be sending the name of the prompt, the alias that we want to add. In this case, we are adding production, and the version of the prompt that we want to set the alias. This is really important because it means that our agent can load the prompt at inference time using the alias instead of a version. So if we are iterating on the prompt, we just create a new version, set alias, and we don't need to redeploy the agent if we want to update the prompt that he's using. Okay, so now let's run our script, our register prompt script. But first, make sure that you have your MLflow server running. If you don't know how to do it, you can follow the setup markdown I created in the documents folder, where you will have a detailed explanation on how to do it. And after you follow these steps, you should have something similar to this without the RAG agent experiment. So now let's run our script. And as you can see, we created a new prompt, a RAG prompt, and we added a new prompt version, version 1. Of course, if we run this again, we can see that a new version was created under the same prompt name. We'll see now this in the UI. As I said, we are registering our prompt in the RAG agent experiment, and we can see under the prompts, you can see here our prompt and the two versions that we created. We added the production alias, and we also added some metadata. For example, we added the author, the language of the prompt, and the task. And you can see here the two messages that make the prompt. You see the system and the user message. Let's continue defining our agent. So now we will build a class that will contain the agent logic. This class, in our case a simple RAG agent class, extends from responses agent. This is really important because this base class is what allows us to have a standardized serving interface that integrates directly with MLflow. This is what allows us to have out-of-the-box MLflow logging, versioning, and deployment capabilities. This class has 4 key methods. Let's start with the first one. So in the init method, we have the initialization of our Bedrock model. We send the Bedrock model ID together with some AWS configurations and also LLM configurations. We also load the prompt from the prompt registry. As I said, we are using the prompt alias to fetch the production prompt. Now let's look into the context, the load context method. This is actually called automatically by MLflow when we are loading the model. In this case, we are initializing our vector store. It initializes our vector store from the pre-built index on disk or creates it from the school policy document if the index doesn't exist yet. We will not go into much detail into how this index is built, but in short, we have a school policy document which is loaded, we split it into overlapping chunks, we embed it using a model in Bedrock, and then we store in a phase index for semantic retrieval. Now let's look into the retrieve relevant documents method. This method performs similarity search against the vector store that we created and returns the top k most relevant chunks. As you can see, this method is decorated with this MLflow trace with the spam of the type retriever. This is what will allow us to automatically create a retriever spam which will contain the documents that were retrieved. This is very important later during evaluation as we are creating a scorer that will evaluate this retriever quality. And finally, the predict method. This method orchestrates the full RAG pipeline. It will call the retrieve relevant documents to get the top k more similar documents when compared with the input question. It will create the context by joining all the chunks that were retrieved. It will then format the prompt by replacing the placeholders in the user question, the context, and the question with the context that was retrieved from the vector store and the user question. And finally, it will invoke the model with the updated prompt, and it will retrieve the answer using the responses agent response. After defining the class, we can see that at the bottom of the file, we have this set model, and we set it as the instance of the simple RAG agent class. This is really important because this is required so that MLflow can discover the agent when we are logging this agent into an experiment using the load model as code feature. Now that we have our agent defined, it's time to log and register it into MLflow. And for that, we'll be using a new script, the register model script. In this script, we will be using MLflow log model as code feature. This is where, instead of using an in-memory object, we pass the path of the agent file via the Python model parameter. So MLflow logs the model using code. We also specified the code dependencies and an input example. This is what allows to validate our agent. At the bottom of the file, you can see that we are setting our agent version, our new agent version, with an alias, in this case, the champion alias. Keep in mind that in a real-world scenario, promotion to champion should only happen after running an evaluation pipeline. This evaluation pipeline makes sure that the agent meets production criteria. If you are interested in more details regarding this pre-deployment pipeline, I cover this topic in more detail in one of my Medium stories. So check the link in the description below if you are interested. Now we can run our script and see what happens in the MLflow UI. Because it's the first time we are running it, you can see that we are creating our vector store from scratch instead of loading it from disk. Again, we will be using our RAG agent experiment. This is where we logged our prompt earlier, and we can see that inside the agent versions tab, you can see a new version. And in the artifacts, you can see all the code that was loaded, including the code for the agent definition and all the dependencies, the source folder, and the configuration file. Now that we have registered our agent, it's time to run our agent against a sample of questions to gather the responses along with the execution traces. To do so, we will be using the create traces script. Following the MLflow setup, the first thing that we are going to do is to load our model using the model alias. Then we'll be looping over the evaluation questions that we have in the evaluation dataset, and we will call the model predict to call the RAG pipeline and produce an answer. We can see that for every question, we have a log of expectations. We are going to log the expected output, what we expect the agent to output, and also the expected context, meaning what should be the context that should be retrieved from the vector store. We also add some metadata to every expectation that we add. In this case, we are adding the source as being a human source. This means that the expectation that we are logging comes from a subject matter expert. These expectations that we are logging, they serve as a reference during the evaluation step. Both the scorers and the judges will compare the agent's actual outputs and retrieve documents against these expected values. After running the script, we can see some changes in the MLflow UI. If we come into our RAG agent experiment, you can already see some changes. In the Overview tab, you can see that we already collect some usage metrics. If we then go to the Traces tab, we can see 10 traces. Each trace corresponds to an evaluation question. And if we go into a specific trace, we can see the retriever span, meaning what was the context that was retrieved from the vector store, and the agent outputs. We can also see both logged expectations. the expected context, meaning what should have been retrieved from the vector store, and the expected output, meaning the target output of our agent. Now that we have defined our agent, captured some traces, and added some ground truth expectations, we are ready to start evaluation. We can evaluate our agent through multiple dimensions. Is the context that was retrieved relevant? Is the answer factually correct? Or for this specific use case, is the answer appropriate for a school-aged child? To evaluate this last dimension, we define a custom LLM as a judge, a child appropriateness judge. We define our judge using the make judge from MLflow. We set the judge name, in this case child appropriateness judge. We give him a set of instructions that tell the judge to evaluate whether the response is appropriate for a school-age child, and a 4-level rating scale, from excellent to bad. We define what model should be used to power the judge and the available rating options. With the judge defined, we register it using the register judge script. In this script, we register the judge under the RAG agent experiment. This is what allows us to not only version the judge, but also to be able to retrieve it later during evaluation with the get scorer. Now let's run the register judge script. Going back to our MLflow UI and to the judges tab, we can see that now we have our child appropriateness judge here. We can see the instructions that we set, the options that he uses to rate the answer, along with the model that we are using to power the judge. Now it's time to run evaluation. In this evaluation, we'll be using the custom judge that we just created, along with the deterministic scorer that will allow us to evaluate the retriever quality, and also judges from Hages and the Rise Phoenix evaluation frameworks. These evaluation frameworks have emerged to provide LLM as a judge capabilities with metrics specialized for multiple aspects of agent evaluation, including retrieval quality, hallucination detection, and response quality. MLflow integrates all these frameworks through the Scorer API, providing a unified interface for evaluation through the MLflow.genai.evaluate. This makes it really easy to combine metrics, compare results, and track the performance of your agent across multiple iterations. Now let's see this in action. First, we retrieve the traces we just created using MLflow search traces. Then we configure our scores. We load the child appropriateness judge from the experiment using the get scorer along with the name of the judge and the experiment ID. We combine it with 3 other scorers in a single list. We will be using the factual correctness judge from Hages, which measures whether the generated response is factually consistent with the expected output we logged as an expectation. We also get the Q&A from Arise Phoenix to evaluate the overall quality of the answer relative to the user question. And finally, the context retrieval, our deterministic scorer that checks the percentage of the expected context lines that actually appear in the retrieved documents. With all of our scores configured, we run evaluation through a single MLflow GenAI-evaluate call where we add the traces that we want to evaluate along with the list of scorers. MLflow runs every scorer against every trace and automatically logs the evaluation results into an evaluation run. After running the evaluate model script, you can see that at the end you have a link to the evaluation results. If you go into the link, you are redirected into the evaluation runs page, where you will have a list of all the evaluation runs that you performed. Looking into our evaluation run, we can see the aggregation of the evaluation results on the top, and you can see the individual evaluation results for each one of the traces. If we enter one of the traces, we can see on the right the results of all the scorers and judges. For example, we can see the factual correctness result, the Q&A result, the child appropriateness judge result, and here you can see that besides having the rate, you also have a rationale explaining the why behind it. And again, you also have the context retrieval. And here you can see that all the expected lines were found. That's why we had a score of 1. You can also have a look into the results of your evaluations. into the Overview tab. If you go into the Quality tab, you will then have a look into the agent quality over time. You start with a quality summary table, which will allow you to know what scores are you using for your evaluation and how many traces did these scores evaluate. Then you have a breakdown of the evaluation results for each one of the scorer that you are using. For the context retrieval and the factual correctness scorer, you not only have the average score and its distribution, but you also have a moving average over time. So imagine that you run the evaluation again maybe in 2 days, then you will get a new data point here. This is what allows you to track the performance of your agent over time. So to wrap up, in this video, we built a complete workflow for building, evaluating, and iterating on a RAG agent using MLflow Unified Framework. MLflow brings multiple evaluation frameworks together under a single interface, removing all the complexity of comprehensive evaluation. Also, it directly connects with MLflow lifecycle management features by linking evaluation results with agent versions and traces. But evaluation is only as good as the judges running it. If judges are unreliable, then teams risking iterating into the wrong direction. Report states that LLM as a judge, they do a great job for general tasks. But as soon as we try to apply them to specific domain tasks, their reliability drops. In our case, when we are using our custom child appropriateness judge, it might miss subtle issues. For example, it might rate an answer with a really high rate, even when the answer contains vocabulary that is too formal for a child to understand. In part 2, we will extend this evaluation-driven development loop. We will add the alignment lifecycle, showing how we can use MLflow MemAlign to close the gap between generic LLM judges and domain expert evaluation standards using a small sample of natural language feedback from humans. Thanks for watching and see you in part 2.